My name is Ryan Vorderman. Um, Doing the homogeneous transformation matrix using the Dennevit-Hardenberg method. Here is my kinematic diagram. Z0 for the first frame is pointing up because that is the axis by which it is rotating around. X0 I used as a basic X direction, and Y0 follow the right hand rule afterwards. The second prismatic joint is oriented in the same way that the first one is, such that the X1 axis, if I pointed it to the right, would follow along the A2 line or joint and intersect with the Z0 axis. So I just kept that orientation for the matrix the same. For the prismatic joint, I had to move it along A5, or the joint A5, and because if I had it out here, the x-axis would not be able to intersect with the z-axis, and so I had to move x such that it followed parallel to A4 and intersect with Z1. And Z2 points downward because that's the direction of motion for the prismatic joint. Y2 follows the right-hand rule. The end effector, I went ahead and made X3 follow parallel to A5 so that it intersected with the Z2 axis. And Z3 goes downward because that's the direction of motion. And Y3, I just left followed the right-hand rule. My joint variables were A1, A2, A3, A4, A5, and A6. These correspond to the vertical, the horizontal, the vertical, the horizontal, and from here, going to the marker, that is A5, and from that position 2, going to the bottom of the marker, that is A6. These are what all those values were. I went ahead and made theta 1 equal to 30 degrees, measured that out with a protractor, and theta 2 equal to 60 degrees. I just kept turning it until it was going straight this way, because that's a 90-degree orientation for the servos. And D2, I went ahead and pulled the marker from where I had it measured at 7.2 down another 2 centimeters. And then I went ahead and measured or found all of these values according to my kinematic diagram for the positions and orientations for the axes. And I went ahead and put them in homogeneous transformation matrices as indicated on the website. Matrix C here represents the 0-1 matrix. Matrix B here represents 1 to 2, frame 1 to 2. And matrix A here represents 2 to 3. That's all 3 matrices that I needed to calculate for. It says that X is 1.56 or 1.58, Y is 6.675, and Z is 1.1. If we look here, we see that if we go out, we get 1, 2, 3, 4, 5, 6. It's about halfway from between 6 and 7 along Y. That's correct. If we go out 1, and about halfway there is the X. That's correct. And going up, if we see here, we see that it is about 1 centimeter from the ground. That is correct too. So the Dennevit-Hardenberg transformation matrix proves true.